Hi dear students, welcome to the next topic from the rotational motion, and today we are going to actually continue the topic of moment of inertia, the theorems which are related with the moment of inertia. So we have a couple of theorems which are connected with or which are related with the moment of inertia. This is what we are going to discuss it for today. Okay, so let's start with the heading. So you can write down theorems in moment of inertia. So the first theorem, two theorem we are going to learn about. The first theorem which is called the perpendicular axis theorem. Perpendicular axis theorem. Perpendicular axis theorem. This is a first part. So this is a first theorem. Okay, perpendicular axis theorem. What is perpendicular axis theorem? States that if you know the moment of inertia of any two axes, then the third axis moment of inertia you can find out. For example, suppose you know the moment of inertia of a body along the ix, moment of inertia along x direction you know, and if you know the moment of inertia along the y direction, then you can find out the moment of inertia along the z direction. So the thing is like, this is a non-parameter, for example, then this is a non-parameter, then this is an unknown parameter here, or vice versa, anything will be fine. So sometimes this is known, sometimes this is unknown, but we don't know whether it is known or unknown. Okay, so this is one combination. Another combination means this is unknown and this is unknown and this is known parameter. So anyway this is possible, either it's an unknown parameter or it is a known parameter. In short, three axes are perpendicular to each other. X, y, z are perpendicular to each other. Are perpendicular to each other. So all these three axes are perpendicular to each other. If so, we can write Iz is equal to Ix plus Iy. This is the perpendicular axis theorem. Moment of inertia of x and y axis is equal to moment of inertia of an z axis. So let's do some questions. Question is, find the moment of inertia. Write down the question. Find the moment of inertia along the diameter of a disk. Along the diameter of the disk. Along the diameter of the disk. Same question may ask for ring also. Okay. So find the moment of inertia along the diameter of a disk. So we know the disk. So disk structure. So we know the axis in which the moment of inertia passing through the center axis, and this value we know is equal to mr square by 2. This already we have learned, moment of inertia of a disk if this will be the axis of rotation. Now what I am going to do means, I am going to consider, so this is a disk is like this. So an axis which is passing through the center and going through the other end. This value we are calculating as mr square by 2. This value we already know. But in our cases we want to find out the moment of inertia along the diameter. Let me take my water bottle cap. So this will be a bit clear. Okay, so we are going to calculate the moment of inertia. So disk means we just passing here and passing through this line, and this is the moment of inertia mr square by 2. Now I am considering two axes. I can consider this is an axis which is passing like this. Now I am considering two axes. One is like this, okay, along this direction, and another axis along this direction. Along this direction. So this is actually an axis which is passing through the center. I am considering another two axes. One is like this, another one is like this. So both axes are, so we have considered like a two axis, right? We are considered like a two axis. So we have this axis which is passing through the center, we know mr square by 2. This is one axis, this is actually a diameter, and this is one axis, this is actually a diameter. But all the three axes are perpendicular. This is this axis and this axis are perpendicular to this axis. So we have two axes. So let me consider the two axes which are running over here. This is one axis Ix, and another axis is along the diameter like this only, and this is Iy, and Iz, whatever given, is passing through the center like this, and this is Ix, and this is Iy, this is Iy, this is Ix. Ix is I diameter, Iy is I diameter, Iz, it's passing like this. So I am writing here Ix plus Iy is equal to Iz. Ix and Iy both are, this is Ix, this is Iy, and now I know this is Iz. So this is actually an I diameter line, this is actually an I diameter. Iz we know it is mr square by 2. So from this one we got 2I diameter is equal to mr square by 2. 2I diameter is equal to mr square by 2. So the I diameter is equal to mr square by 4. So mr square by 4 is the moment of inertia of a axis of a disk along the Z axis. So we have actually considered like a 3 axes. We can say Ix and Iy and Iz all are perpendicular to each other. Okay, let me close my water bottle. Okay, so let's go to the next question. Fine. Find the moment of inertia of a square lamina. Find the moment of inertia of the square lamina along the along an axis passing through the center. Along an axis passing through the center. Passing through the center. What is the meaning of this one? We have a square lamina of side A length, and we have an axis like this, and which is passing through the center, and this is an axis of rotations. So for this axis we want to find out the moment of inertia. Let me consider this as x dash, but we know the moment of inertia of two axes which is passing like this, and the another axis which is passing here. These two moment of inertia we know. This is called Ix and this is called Iy. Both values we know. What is the moment of inertia along this axis? It is ma square by 12. Okay, what is along this axis? This is also equal to ma square by 12. In a rectangle we have seen ml square by 12, mb square by 12 in the previous session. Here L and B are same because it is a square plate. So ma square by 12 e axis ma square by 12. In case of a rectangle we see this is the breadth a is equal to b e side mb square by 12 എന്ന് വരും. ഈ സൈഡ് എടുക്കുമ്പോൾ this is the length axis, so ml square by 12 എന്ന് വരും. In case of rectangle, last video we discussed, but here as it is a square, both sides are equal. So now it's quite simple. We'll apply the formula Ix plus Iy will be equal to Iz. This already we know. We'll substitute the value, and this one is ma square by 12 plus ma square by ma square by 12 is equal to Iz. So how much will come? Ma square by 6 is equal to Iz. Iz in a value ma square divided by 6. Okay, hope this is clear to you. Good. Let's move to the next theorem, and which is called parallel axis theorem. Parallel axis theorem. Okay. Parallel axis theorem. So listen to the board clearly. The second theorem is parallel axis theorem. Parallel axis theorem. What is parallel axis theorem? States that if you know moment of inertia of an axis, that is called Ik, it's a non-axis, and if you want to find out the moment of inertia of another axis which you don't know, I of unknown axis, and the perpendicular distance between them 90 degree is A, then we can say moment of inertia of an unknown axis is equal to moment of inertia of the known axis plus mass into square of the distance between these two body, ma square. So mass of this body. So I unknown equal to Ik plus mass into a square. This is the parallel axis theorem. So parallel axis theorem will help us to find out moment of inertia of an axis and that axis is called IUK. And in that axis, what is the key point with us? In that axis, if you know the moment of inertia of one axis and if you want to know the moment of inertia of another axis, you can find out the unknown axis moment of inertia value from the non-moment of inertia values. Let's do a question, then it will be clear. So write down one question. Find the moment of inertia. Find the moment of inertia of a disk. Find the moment of inertia of a disk along the tangent parallel to diameter. So we have a disk. We are going to find out a moment of inertia of this axis, but the speciality of this one, this is given, it is parallel to this axis. It is parallel to, and this is parallel to the diameter line. So this is parallel to the diameter. So this is a diameter line. So this is a known axis. What is the moment of inertia of a disk along the diameter? We already know, right? mr square by 4. And this is an unknown axis and this is a tangent. Okay, this is a tangent and we want to find out this moment of inertia value. What is the distance between the two value? I mean the distance to the center is always the radius. So we can find out I of unknown axis is equal to I of known axis plus mass into m into square of the perpendicular distance. Perpendicular distance is what? R. So mr square. Non-axis value we already know, mr square by 4. From the previous question we find out using perpendicular axis theorem, moment of inertia of a disk along the diameter, mr square by 4 plus mr square. So this will give rise to 5 mr square divided by 4 is the right answer for this question. Okay, great. We are going to do the next question. So the parallel axis theorem is clear. We want two axes. One axis moment of inertia we know. Another axis moment of inertia we want to know. Okay, good. So let's continue. Let's continue. Over will be here. The next question. Find the moment of inertia of the road along x dash axis. That means this is a road having length L, having mass m. We want to find out the moment of inertia at one edge. So how to answer this one? In order to find out the moment of inertia of this axis, we know this axis value, right, which is passing through the center, ml square by 12. And what is this? This is an I unknown axis. We don't know the moment of inertia of this axis. This axis, actually the question is asked us to find out. What is the distance between these two bodies? Total length is L. So half of the distance will come, L by 2. Now we'll apply the formula IUK is equal to I known axis plus m into a square. Okay, so what is known axis? It is ml square by 12 plus m into A is the distance between these 2 points. So that is L by 2 the whole square. So this will come as ml square by 12 plus ml square by 4. So answer will come 12 as taken as LCM and answer is ml square by 3. ml square by 3 is the right answer. Correct? 1, 3, 4. 4 by 12, ml square by 3. ml square by 3 is the moment of inertia of a road along its one end. Very important. Please note it down. Okay. Now we'll go and solve the next question from the theorems of moment of inertia based on parallel and perpendicular axis theorem. Okay. Find the moment of inertia. Question is, find the moment of inertia of a solid sphere along the tangent. So this is a solid sphere, and this axis moment of inertia we already know. This is 2 by 5 mr square, I known axis. We want to find out moment of inertia of this unknown axis. That is a question. So we know what is the distance between them. It's called the radius r. So capital R, small r, capital M, small m. Whatever you would like to have, you can take. No issues. Depends on the question. Ik plus m into m is small letter I have taken in the question. So it is mr square. So this is 2 by 5 mr square. We know the moment of inertia of a rod which is passing through for a solid sphere, and the axis of rotation is like this, 2 by 5 mr square and plus mr square. So answer is 7 mr square divided by 5. It's quite simple, direct question. It's more or less similar to the disk. Okay, fine. Next problem. The next question is related to the moment of inertia again by using parallel and perpendicular axis theorem, but let's see and do. Okay, this actually it's a bit tricky question, but let's see how we can do this one. Okay, so the question is find the moment of inertia along the hinge. Hinge is normally marking with a cross sign. So this is a rod, and which is connected over here. Two rods are connected, and its mass is m, length is mass is m, length is. So this is the rod and axis along the hinge passing into the paper. In your case, my case is into the board, but for your case I am writing into the paper. So which means we want to find out the moment of inertia of a rod of this L-shaped structure, and the axis which is passing through like this into the board, axis is into the board. So we want to calculate the moment of inertia of an axis which is passing into the board. How to calculate, how to do that? It's quite simple. So we have two masses will be there, number 1 and number 2. So for this one, so we have two moment of inertia, I1 moment of inertia and I2 moment of inertia. So total moment of inertia is equal to I plus I1 plus I2. We have to find out for I1. What is I1? So this moment of inertia I know for I1. So first we will take the rod of I1 alone. So I1 in a moment of inertia, just before we have calculated, right? So what is the moment of inertia of a first rod of mass m and length L along this one? If it is like this or if it is like this, any format, it is passing through one edge. Okay, so one side would pass. So each side would pass in the moment of inertia I know, this side would pass in the moment of inertia I want to find out. So idana idinte axis. Axis means it is something like it's passing like this. I mean, you can consider just like a road. So this moment of inertia, or or this moment of inertia, this road you can place it in any direction. If this is the road, you can place it like this. Okay, this is the road. So this moment of inertia is ml square by 12. This moment of inertia is ml square by 12. This moment of inertia is ml square by 12. So center kuda pass in ml square by 12 aanu. Oru edge kuda pass innathu, it is ml square by 3. This we already know. Okay, in second cases we want to find out the moment of inertia. So moment of inertia of this rod. In the second rod, so first rod is clear. This is for the first rod. Now we'll go for the second rod. Second rod, this is an axis which is passing through the center. I told center could pass in any position on the axis. This is a 3D structure. This structure will be look like this one. First rod, second rod. So moment of inertia of this axis. So this axis value I know ml square by 12. Using parallel axis theorem, this I find out ml square by 3 itself. Previously I find out ml square by 3. Now the structure is look like this one. Now I have an axis over will be here, and E axis in the value ml square by 12. I told this is also ml square by 12. This is also ml square by 12. This is also ml square by 12. Now I know this axis is ml square by 12. I have another axis which is passing like this. That is actually given in the question. It is into the board. So it is one side, E side ml square by 12. this side how much? ml square by 3, because parallel axis theorem, just before we told, just 5 minutes before. So this is found. Next we have another axis. So this is one axis and we have another road will be here. So this road I have to consider a parallel line. So this is center line. So this line in the moment of inertia you already know ml square by 12 for this road. Now I want to find out moment of inertia here because of the second road. This is for the first road. This is for the first road. Upper second road in the perpendicular distance we have to calculate. Perpendicular distance. What the distance will come? This is L. This is half L by 2. So Pythagoras theorem will apply L square plus L by 2 the whole square. L square by 4. So for the second road we have calculated moment of inertia of unknown axis. Parallel axis theorem we are applying. So moment of inertia of a known axis. What is a known axis? ml square by 12. This is the known axis. ml square by 12 into plus mass into square of the distance between them. So L square plus L square by 4. This is the because of the second road. Because of this second road. Hope it is clear. Okay, I will explain it once again very clearly. Listen to my hands. This is one road and this is second road. So moment of inertia along this axis they are asking. So you know for the first road is a red one, second road is a blue one. So the first road ml square by 12, this is ml square by 3. This is already written there. Second road idana one axis. അപ്പോൾ സെക്കൻഡ് റോഡിക്ക് ഇതിന് പാരലൽ ആയിട്ട് അല്ലെ രണ്ട് ലൈൻസിന്റെ പെർപെൻഡിക്കുലർ ആയിട്ടുള്ള ഡിസ്റ്റൻസ് വേണം. ഇതാണ് ഒരു ആക്സിസ്. അടുത്ത ആക്സിസ് ഈ ഒരു ബ്ലൂ കളർ പെന്ന്, അതായത് ഈ ടി ഷേപ്പിന്റെ ലെഗ്, ഇതിന്റെ സെന്റർ കൂടെ പാസ് ചെയ്യുന്നതാണ് നെക്സ്റ്റ് ലൈൻ. സോ ഇതിന്റെ സെന്റർ കൂടെയാണ് ഒരു ലൈൻ പാസ് ചെയ്യുന്നത്. നെക്സ്റ്റ് ലൈൻ വിൽ ബി ഹിയർ. അപ്പോൾ ഇതിന്റെ പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ്, ദിസ് വൺ വിൽ ബി ദ പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ്. That is actually this value we calculated, and now we got the moment of inertia. This is a value of I1 and IUK is equal to what is called I2. Next we have to find out the total moment of inertia. Total moment of inertia is how much? ml square by 3 plus ml square by 12 plus idine simplify na 5 into 4l square 1l square 5l square. So 5 ml square by 4. We have to take an LCM. Let me take LCM as 12. 3. So 12 3 4 times. So 4 ml square. 4 ml square plus 12 will 1. So it is ml square. 12 will 4 3 times. So 15 ml square. 15 ml square. So 15 plus 4 19. 20. 20 divided by 12. 20 divided by 12 is how much? 20 divided by 12. 4 which we can cut, right? So 5 ml square by 3 varum. 5 into 4 23. So 5 ml square by 3 is the right answer for this question. So here how many parallel axes will be here? First we applied for the first road parallel axis, because this moment of inertia I already know, ml square by 12. I actually applied the parallel axis theorem. This is what we solved in the previous question itself, right? I unknown axis equal to ml square by 12 plus m into l by 2 the whole square, and this will get ml square by 3. This is equal to I unknown axis, or this is equal to I1 for the first road. Similarly we find for the second road. So here the key point will be, here we have to find out the perpendicular distance between the two road. That is actually the parallel axis theorem intended to do. So next we are going to learn about some numericals which are based on the torque. Okay, so torque we already learned. Torque is equal to R cross F and torque is equal to I alpha. These are some of the numericals which are very commonly coming for entrance examinations, and we'll do some different flavors of this one, which include the torque, alpha and other rest of the things. I mean, it is actually a collection of the rotational motion equations with the torque in the conceptually include in some best numericals. Okay, so write down the heading, some important numericals on torque, exclusively with respect to torque. Okay, these questions will be coming with this very frequently. Okay, so the first question will be, let me take my questions over here. Okay, find the value of alpha. Find the value of alpha and angular displacement and the angular displacement. Find the value of alpha and the angular displacement theta in time t. Questions is also given with a diagram and with an hinge which is fixed over will be here, and you are giving a force over will be here. Okay, and hinge is not over here, hinge over will be here. So total length will be equal to L at the center and F. So whenever you see some question in which you able to, I will tell you it's a kind of a short trick, I can say. Okay, whenever it is asked us to find out, once you get some question in a simple way, once you get some question and question, while reading the question you understand there is some turning effects will be there. Definitely once you give a rotation, once you give a force will be here, this will get turned. So two things you have to analyze in the question. If there is a turning effects will be here, definitely in your question you have a torque equations will be coming, because the turning effects is related to torque. Second one, when alpha is coming, if these two combinations are coming, you know torque is equal to Rf, which is equal to I alpha, R cross F. Okay, next we'll find out what is R. R is the perpendicular distance from the hinge to the application of force. L by 2 ആണ് ഇവിടെ വരുന്നത്. So we'll substitute for R, L by 2, force is capital F. I is the moment of inertia. I, where we have to calculate the moment of inertia. Moment of inertia along the axis of rotation. ഇതാണ് rotate ചെയ്യുന്ന axis. ഈ ഒരു സൈൻ ഇൻഡിക്കേറ്റ് ഇറ്റ് ഈസ് ആൻ ഹിഞ്ച്, അതൊരു ഹിഞ്ചാണ്. സോ ദിസ് ഈസ് ദി ആക്സിസ് ഓഫ് റൊട്ടേഷൻ. വാട്ട് ഇസ് ദ മൊമെന്റ് ഓഫ് ഇനർഷ്യ വിൽ ബി ഓവർ ഹിയർ ml square by 12. And what will be the rest? Will be the alpha. So we have to find out L and L will be get cancelled. 2 and 12 will be get cancelled, become 6. So alpha is equal to 6f divided by ml. 6s divided by m is the answer for the value of alpha. Next we have to start to find out the value of, so value of alpha we calculated. Next one, the value of angular displacement. How to find out the angular displacement? Angular displacement, we will apply the any equations. Anyway, we know we got alpha. Okay, alpha is only depends upon the force. So whenever the force, here the given force equal to F. F is a varying one? No, F is a constant one. F is equal to F, that's all. It's either 10 Newton or 4 Newton, so it's fixed. So it is a uniform accelerated motion equation, or acceleration is constant. So v is equal to u plus at, s is equal to ut plus half at square, v square equal to u square plus 2as. All the one dimensional motion equation, corresponding rotational motion equation you can apply. So we want to be find out theta. Theta equal to omega 0 t plus half alpha t square, starting from rest. So this will be 0. So this force is not continuously applying. When you are looking, it is starting from rest. This I have not added to the question. You can add starting from rest. Starting from rest. So that is missed in the question. Sorry for that. So this is 0 plus 1 by 2 into alpha. Alpha is 6f by ml. 6f divided by ml into t square. So answer will be equal to 3f. 2 and 3 will get cancelled, become 3. So 3f t square divided by ml is the angular displacement. Hope this is clear to you as well. Okay, fine. So let's move to the next question. I have the next questions with me. So let me first clean the board. Okay, so this is actually a torque equation plus rotational motion. Theta equation is also came in this problem. Depends on the question. Okay, we have to use the required equations and solve it. Only practice will help you to get what you want to do in each cases. Okay, question will be, the next question will be here. Find the angular velocity. Find the angular velocity of the disk after 5 seconds. After 5 seconds, the wheel is rest initially. The wheel is rest initially. Okay. Question is given a diagram as well, and this is a hinge, and with respect to the hinge, and the disc is placed, and the disc is rotating along this axis. The parameters which are given, I will be equal to 0.2 kilogram meter square moment of inertia, R will be equal to 20 centimeters. These are the things which are given. Okay. So what are the things we want to be find out? We want to be find out to omega. So first you have to look, so force of 20 Newton, right? 20 Newton. These are the things. So first when we look, find the angular velocity of the disk after 5 seconds. The wheel is rest initially. I is equal to 0.2 kilogram and R will be equal to 20 centimeter. This is given. So if turning effects will be there in the question, yes. So torque is involved because it is rotating. So torque is involved, and we want to find out alpha, omega, theta. In all cases we can apply our torque equation. So what is really in our torque equation? What is the torque equation? States that torque equal to RF equal to I alpha. First stage, RF equal to I alpha. R is the radius. What is the radius value which is given here? 20 centimeter. This R is perpendicular to F. Whenever the force in the point R will be here. You know everywhere R is 20, but force in the point R is like this. So 20 centimeter, 20 into 10 power minus 2, F is 20 Newton, I is how much? 0.2 into alpha. Alpha we don't know, we have to calculate. So this is like 400 into 10 power minus 2 divided by 0.2 equal to alpha. So 400 into 10 power minus 2 means it is just 4. 4 divided by 0.2 is equal to alpha, and we got alpha is equal to 4 by 2, so it becomes 20. So 20 radians per second square alpha. Question is asking like omega, so I can use any motion equation. Alpha is constant because force is constant. Force is not changing, so alpha will be constant. You can use any 3 motion equations to find out the value of omega. So omega has to find out omega is equal to omega 0 plus v is equal to u plus at alpha t. So omega is equal to, system is initially rest 0, alpha value 20, substitute 20 into time t is equal to after 5 seconds, so 5. So answer is 100 radians per second is the right answer for the question. 100 radians per second. Okay. So let's move to the next problem. You have to practice a lot question comparable to other chapters, like there are some chapters will be there, right? Maybe students will say it's very difficult, but it's not actually difficult. For example, ray optics, rotational motions, there are certain chapters which you have to loss of motion. This kind of chapters you have to practice a lot of questions, number of questions. 2-dimensional motion comparable to 1D motion, I am saying 2-dimensional motion. These are the things which you have to practice a lot question, maybe 300 questions from a chapter. Then only you will be very confident to do any upcoming examination questions as well. So let's move to my next question. A wheel with moment of inertia 2 kilogram meter square and rotating at 50 rpm. Rpm means revolutions per minute. Okay, rotating at 50 rpm is brought into rest. Rest load, we are taking that wheel into the rest. Find the torque required to bring. Find the torque required to bring into rest in 1 minute. Okay. What are the things which are given to us? Okay, you have to tell me what are the things which is really given in the question. A wheel with a moment of inertia. So let's answer. I will be equal to 2 kilogram meter square is given. Rotating at 50 rpm, 50 revolutions per minute. I am writing very clearly revolutions per minute, which means in 1 minute 50 revolution. In 1 minute 50 revolution. Number of revolution, number ആണ്. Okay, so which means 1 minute 50 revolution. 50 revolution means how many radians? 1 revolution is 2 pi radian. So 50 revolution is 50 into 2 pi radian. ഇതാണ് തീറ്റയുടെ value in 1 minute. 1 minute means how much seconds? 60 seconds. 60 seconds ilana 50 into 2 pi radian. 50 into 2 pi radian. So in 1 seconds how many radians? 50 into 2 pi divided by 60 radian ആണ് ഒരു സെക്കൻഡിൽ റൊട്ടേറ്റ് ചെയ്യുന്നത്. So 50 into 2 pi divided by the value of radians. So 50 revolutions in 1 minute. 50 revolutions in 1 minute. Okay, so the wheel which is rotating having a moment of inertia of 2 kilogram meter square, rotating at 50 revolutions per minute. We know 1 revolution is 2 pi, so 50 revolution is equal to 50 into 2 pi. Okay, so we want to convert, we know this is a number of revolutions in 1 minute. 1 minute means 50 into 2 pi radian, which is completing over will be here. And what we required, find the torque required to bring it in 1 minute. 1 minute we required to get the torque required. So it is rotating with an RPM of 50 meter per second, brought into rest, brought into something which is rotating initially. I have taken into rest means what is the value of final velocity? Final velocity is 0. Yes, the steps are clear. 50 revolutions per minute means 1 minute 50 revolutions. 1 revolution is 2 pi radian. 1 minute. So 1 minute is 60 second this much radians. So 1 second 50 into 2 pi divided by 60 radians. So we want to find out how many revolutions, find the torque required to bring it into 1 minute. So we'll find out. We have a motion equations. Omega is equal to omega 0 plus alpha t, v is equal to u plus at. Omega is the final velocity which is 0. Omega 0 is the initial one. Omega 0 is what? Radians per second. This is actually 1 second, number of revolutions per second. Okay, so it is radians per second. So this is actually our omega number, radians per second, right? Radian per second. 1 second, how many revolutions? So this, it's 50 into 2 pi divided by 60 into omega, v is equal to u plus at, alpha, v is equal to u plus alpha into time t is how much? 60. 1 minute, number of completed in 1 minute. Okay, so we know alpha will be equal to 50 into 2 pi divided by 3600. So 50 into 2 pi means 100 pi. 100 pi divided by 3600. 0 zeros cancel, so it become pi by 36. What pi by 36? Negative sign will be there, right? One negative sign. So minus pi by 36 will come. Minus pi by 36 alpha. So now I know the wheel is rotating. Wheel will have what effect? Rotating effects will be there. So what we need to be find out? We need to be find out the torque required for them. Okay, so we need to find out the torque. How to find out the torque? What is the formula for torque? Torque will be equal to, so let's continue over here. Torque will be equal to what? Torque is equal to I alpha, which is equal to RF. Moment of inertia will be given. What is moment of inertia? 2 is given. Alpha is pi by 36. What is the minus indicate? Acceleration minus indicate it is a decelerations, which is equal to, what is the radius of the wheel which is given in the question? Any radius value which are given in the question? 50 rpm, and which is required to be rotated. Okay, we don't want to use this one, right? They only ask us to find out the value of torque. Not R and F is not required. You can use any one of this formula. So I am using this one. So what I will get? Pi by 18 Newton meter is required. Negative sign only indicate it is decelerating, speed is decreasing, but that doesn't matter to us. So the torque required will be equal to, if you put minus also no problem, this indicating you are applying a torque against the direction of motion. The wheel is rotating in this direction, you are applying a torque in the opposite direction. Okay, to hold it back, you are trying to turn it back in the other directions. So that is up to us how we are doing. Okay, fine. Okay, so let's do the question. Next problem. Let me clean the board over here. Question, here it is given a structure, a diagram. Before that, find alpha and A of the given diagram we have a diagram which is given, and here it is a hinge, and we are actually applying a force like this one horizontally, making 37 degree. We want to find out the value of alpha and the other things. The length of the rod, which is given as L. Okay, now once you are applying the forces, we have to the first stage means we have to split this into force into two components, right? So once we split this force into two components, one force along this direction, and this is F cos 37, another force, okay, another force in the vertical direction, right? There are two forces will be there, one is like this, one is like this. So what is the other force will be here? That is called F sin 37. So as I told, we know the 37 value triangle. In many places we have drawn 3, 4, 5. 3 is the opposite side. So which force is contributing to the torque? Torque is contributing by F sin 37, because that is making 90 degree with the R vector. So we know torque is equal to R perpendicular multiplied with the F perpendicular, and which is equal to I alpha. What is R perpendicular? From the hinge to the application of the forces. In the previous problem, our hinge will be here at the middle, now here. So the length will be equal to length into F sin 37 is equal to I in the value. I value, where? I value not here, I value has to calculate over here. So what is the I value over here? At one edge, ml square by 3, hinge lana moment of inertia into alpha. Okay, so F sin 37 means opposite side by hypotenuse, so it's 3 by 5. So LF 3 by 5 is equal to ml square by 3 alpha. So we can find out the value of alpha. So alpha from this equation is what? 3 into 3, 9F. So L and L will be cancelled. So 3 into 3, 9F. Okay, 9F, and divided by 5 ml. This is the value of alpha. And we need to calculate the value of A. So A means A indicate A net. A indicate A is equal to A net. So you have to find out AC square plus AT square, because it's a rotational motion. Okay, so you have to know the centripetal, and you have to know. So this is just okay. So the turning effects, the question is not asking after a long time. When you are applying the force, it is just started to turn. At this point, we know AT will be equal to R alpha. r alpha. So what is the radius will be there when this is started to rotate? What is the radius will be there? Length. So it become L alpha. So what is alpha? 9f by 5 ml. So L into 9f divided by 5 ml. L and L will get cancel. It become 9f divided by 5 m. So this is clear. What is AC? AC is the centripetal acceleration. It is v square by r. Okay, so here v is equal to r omega. V is equal to r omega. So you know v is equal to r omega. So r square omega square by r, we know it is equal to r omega square. But the point or will be here, very important, remember like that, AC is equal to 0 just after starting the motion. Just after starting the motion. Just after starting the motion. The reason for this reason is omega equal to 0. So the AC means centripetal acceleration. Centripetal accelerations ഒരു ബോഡിയിൽ ഇൻടേക്ക് പണതൊക്കെ it will take some time. Some time means just after the rotation of the body, the centripetal acceleration will not take it after. Only tangential acceleration will be there. ആ ഒരു time period, okay, after some time only centripetal acceleration are started to regain. അതൊരു പീരിയഡ് ഉണ്ട്, അതൊരു ഡെൽറ്റ ടി പോലെ ഒരു ടൈം ഇൻ്റർവെലിന് അപ്പുറം. After that only centripetal accelerations are started to act on a body. Just after application, just turning and enter സമയത്ത് only we have AT, there is no AC. Now what we'll do, we will use this one. We'll use this one in the formula. We'll substitute 9f divided by 5m the whole square plus 0 square. Answer is 9f divided by 5m meter per second square is the answer to the question. Very important. Okay. Fine. Let's go around for this one. Okay. So the next question, let me clean the board and we'll go to the next problem. Next numerical. Okay, this model you can expect for NEET as well as for engineering. Wherever you write, whatever you write. Entrance point of view, this is important. This kind of concepts, things are important. Okay, so let's start with the next question. Questions will be, find the value of alpha. Find the value of alpha when the road makes 37 degree. Diagram is also given to you. So a rod which is fixed on the hinge, and now the rod is going to rotate. Now will be here at 37 degree positions. Okay. Find the value of alpha when the rod makes 37 degrees starting from rest. Rest position ആ ബോഡി സ്റ്റാർട്ട് ചെയ്യണം. ആ ബോഡി സ്റ്റാർട്ട് ചെയ്യുമ്പോൾ അതിൻ്റെ വാല്യൂ ഓഫ് ആൽഫ കണ്ടുപിടിക്കണം. Okay, that was the aim. So 37, once you given 37 triangle window, this is 3 and this is 4 and this is 5. So what all the forces are acting on this one? This is a hinge. I know this is a force which is acting from the center of mass, and this is called the weight. Idinte mass m, length l. This is the weight mg. Okay, so we have the two components. One is a component along this axis, one is perpendicular to this one. Okay, and so if you know, you have this line. Okay, and you have this line, which means if you have drawing one line like this one, this is how much degree? Similar to this one, 37 degree. How much this degree will come? 53 degree, right? 53 degree will come. If this is 53 degrees coming, what is this one? 37 degree will come. So what is this component will come? mg e side cos 37. This mg cos 37. What is this one? mg sin 37. Or you can write cos 53. But cos 53 value I don't know. I know only 37. Okay, that is in the standard value which we'll remember. So mg cos 37 is said mg sin 37. So from the hinge to the application of force, this is my r vector. R vector is equal to vector R equal to L by 2. So the force and R are perpendicular. So I know torque is equal to R perpendicular into F perpendicular is equal to I alpha. What is R perpendicular? L by 2. L by 2. What is F perpendicular? Mg cos 37. So mg cos 37 is equal to I, moment of inertia along one end, ml square by 3 into alpha. So L by 2 mg into what is cos 37 in our case? Cos 37 4 by 5. So it is 4 by 5 is equal to ml square by 3 into alpha. So what will cancel? M cancel, L cancel, M cancel, L cancel, 4 cancel, F2, 4 with 2 cancel. So 2 by 5 G will be here extra. 2 by 5 G. What is extra will be here? 1 L, 1 alpha, 1 3. So we want to be find out the value of alpha. Alpha is equal to 3 into 2, 6G. So 6G divided by 5L. 6G divided by 5L is the answer. So there is one question will be there, I think 2 years back for JE main entrance examination. Instead of giving the value of 37 degree, they have given the value of theta. So what will come over will be here, cos theta will come, and cos theta will carry till the end, till to the answer. So you have to work accordingly. Okay, so let's move to the next question. Good. Okay, so please take the next question. Next question is, find the acceleration of block. Find the A of block. Acceleration of the block has to find out. If there is no slipping between, if there is no slipping between rope and pulley, which means a structure which is given like this one, and hinge then a fix edukano, then a rope wound edukano. This rope rotate this pulley rotate, pulley rotate this mass. So what is the acceleration of the mass? This one. Okay. Fine. Here we need to find out acceleration. Okay. Okay, I hope you know already some shortcuts from the laws of motion which required to apply over here. So let's see. So this is a force which is acting over will be here. So we will write the first steps as we know rotational motion. RF will be equal to I alpha. R should be perpendicular and F should be perpendicular. R is actually a force which is acting over will be here. So this is the R and this is the tension. Okay, it's above or below, whatever it is. So R into tension is equal to, this is a disc. Either pulley structure is something like a disc. We can consider the disc moment of inertia or just simply I with respect to alpha. So we got alpha is equal to RT divided by I. R is the radius and T is the tension. But question is always interested about this accelerations A. So this is an acceleration, is a centripetal or a, so here we have this acceleration is actually a tangential acceleration. So we want to be we know the relations between AT and alpha. AT is equal to R alpha. So alpha instead of alpha, here AT is given in question as given in the question as A. In the question it is given as A. So we will substitute alpha is equal to what will come? AT by R. AT by R is equal to RT by I. Okay. Alpha is equal to AT divided by R. So what we will do? AT is equal to A is given in the question. So A by R is equal to RT by I. RT by I. So we can write one formula for maybe tension. So tension T is equal to, from this one, tension T is equal to what will come? IA by R square. IA by R square. I will keep this formula here for later references. Okay. This is what I have derived. Now once I draw the free body diagram, I have a couple of equations, right? What are the what is the free body diagram for this one? Now I will do FBD, free body diagram for this mass. What all things will be there? Tensions will be here, mg will be here, accelerations will be down. So I will write upward force T minus mg is equal to minus ma, throughout multiplying with the minus. So mg minus T is equal to ma. T minus mg is equal to ma. Now balance steps I am writing here. Now this I am giving as equation number 1 and this I am giving as equation number 2. Now what I am going to do means equation number 1 is placed into equation number 2. So mg minus T, T ke badala we are substituting IA by R square is equal to ma. So if you take it to the right hand side, what you will get? Mg is equal to A into m plus I by R square. So the acceleration is equal to mg divided by m plus I R square. M plus I by R square. ഈ പുള്ളിയുടെ കേസിലെല്ലാം normally this will consist as a disk. പുള്ളിയുടെ ഡിസ്കോ ആയിട്ടാണ് we are assuming. So acceleration is equal to mg plus m divided by I R square. Okay, you don't want to derive it like this one because it will really take some time, but you want to know how this is are coming, okay, at least once. But we have a shortcuts to find out this one as well, right? We know for a single body what is the acceleration? Forward force minus reverse force divided by sum of the masses. Forward force means what? Downward force, mg. Any reverse force? No, it is 0. Sum of the masses, m. So our acceleration is actually mg divided by m. So whenever the rotational motion criteria are coming, which means the pulley and the ropes and the pulley is rotating, there is no slipping, so which means it's an acceleration. Whenever the rotational motions are coming, whatever you have learned in the laws of motion, in additionally in case of rotational motion, what you have to do, the already denominator plus I by R square you add extra. So the parameter which you have to add extra is I by R square. Forward force minus reverse force divided by sum of the masses, you know. So mg minus, there is no reverse force here, so 0 by m. So mg by m, and extra you are adding I by R square to the rotational motion equation. This is the way you can connect. Okay, suppose I am taking little bit of space over here. Suppose, so this is clear, right? Suppose instead of asking, now here it is just a single structure, okay, single one body structure. Now if there are two masses are given, okay, and two masses are given, and what is the question? Find the same thing if there is no slipping and it's purely a rolling motion for two body structures. For two body structures similar to this one, what we have learned, this is a pulley system and this is a rope, and over here m1 and over here m2. So we know m2 which is greater than that of m1, this is a criteria. So acceleration is equal to forward force minus reverse force divided by sum of the masses. Forward force is m2g, reverse force is m1g, sum of the masses is m1 plus m2. But here extra, what will come? Extra, what is come? I by R square plus I by R square. I is for what? I is for pulley, the rotating body. I for pulley. I is for the pulley or the rotating body. What is the rotating body will be here? Only the pulley system will be there, right? That is the only things which you have to remember. You know this stuff already from laws of motion. Extra, we are adding a one small capsule into this one so that you will get the equation for rotational motion. Hope this is clear to you. I hope it is clear to you. Okay, that's good. Okay, so important numericals on torque is over. We are moving to the next topic. Good. So let's go ahead. Okay, understand and then learn. Small kuti topics are there. Kinetic energy of rotation, rotational motion, the kinetic energy. We know linear kinetic energy of linear I am writing. What is called? Half m v square. Now if you come to kinetic energy of rotation, the only difference is half m into, instead of v, r square omega square. V, because you know v is equal to r omega. What is mr square? Yes, so kinetic energy of rotation is mr square. Mr square means 1 by 2 I omega square. So this is the kinetic energy of rotation. Okay, next one, next topic, work done by torque. Work done by torque. So this is wherever we have studied this one. This we have studied in laws of motion, this we have studied in one-dimensional motion, and this we have studied in two-dimensional motion, this we have studied in work power energy, and blah 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 blah. Many chapters we have learned, right? Half mv square. So this is the first time. Work done by force, W is equal to F dot S if F constant. If F constant. Or we'll write F is equal to integral F into ds if F is varying. If F is varying. Where you have learned this? You have learned this in work power energy. Work is equal to force into S. Work is equal to integral F into ds. This same thing we are taken into the rotational motion. So work in rotational motion is equal to tau into theta. Tau into F theta, S theta, F torque, S theta. If tau is constant, if tau is constant, if tau is varying, so work of rotation will be equal to tau into d theta integral tau into theta if tau is varying, So this is important for us to know whatever given in the bracket. Okay, perfect, pakka. Okay, we'll move to the next topic. Next one, another important topic. We'll do some questions on based on all this stuffs later, because these are small topics, chota topics. We want something bigger, right? Yes. Next topic, write down, girls and boys, please write down the heading called, my body is sliding down. Okay, angular momentum. I told in rotational motion, if you multiplied with the r with a linear quantity, rotational quantity, you will get a linear quantity, right? Okay, so v the corresponding parameter is omega. So what you have to multiply with? R. You will get r omega, or omega cross r important. I told acceleration. What you have to multiply with acceleration, the corresponding term is alpha. What you have to multiply with? R you will get. So same way here also. What is the momentum? P. You want to get what you want to get? Angular momentum. What you want to multiply? R. So RP. Okay. Normally we'll use a small letter instead of capital letter. That is a sign convention which is followed in the NCERT book. So we'll use small letter r, and small letter r. Okay, RP. So angular momentum is equal to r cross p. How to find out the direction of angular momentum? Direction of the angular momentum find out using cross product of two vectors. Sir, cross product of two vector indicate right hand palm rule or right hand thumb rule. Thumb will give the direction of L. R is the direction of your palm. Other four fingers is the direction of your P, and thumb will give the direction of L. L is equal to RP. What is the unit of angular momentum? Tell me, boys and girls, what is R? R and the unit is what? Meter. P. P means P. What is P? P is equal to mv, right? mv. So mass in the unit kilogram, velocity in the unit meter per second. So answer is kilogram meter square per second. Sometimes this question will be asked the dimension formula of angular momentum in which chapter? Units and dimension, important. So what is the dimensional formula? Dimensional formula. Tell me what is dimension formula? Kilogram m l square t power minus 1. That's all, over 4 marks. Okay, m l square t power minus 1. Okay, substitute. But is the angular momentum is over? No sir, angular momentum is not over. Listen again here. Angular momentum, alternate equation. Angular momentum, alternate equation. Why we need an alternate equation? If something will happen to the first equation, we'll use second equation. No, it's not like that. It's not a backup tire as like vehicle. Correct? It's not like that. Depends upon the question. Either I will use this one or I will use this one. So what is alternate equations? Angular momentum. Can somebody tell me? R into P mv. So R into m into, instead of v, r omega. So what I am getting? mr square omega. What is mr square, boys? mr square is I. So L equal to I omega. Important. Two equation, R cross P, I omega. Both should be there on your cerebrum. Both should be on your cerebrum. Never supposed to forget about it. It's very important. L is equal to I omega. L is equal to R cross P. Okay. So let's do a beautiful question. Then we'll come to a beautiful answer. Okay. So let's have the questions with me. Okay, we'll do some problems, right? For quite some time we are not doing any questions. We'll do some questions related to angular momentum. Very important on angular momentum. Very rarely a question paper is passing without angular momentum. So angular momentum is very important in short. Okay, so angular momentum is pakka. High chance of asking questions from the topic of angular momentum. So let's do some of the questions. Before going to that, I have to give you some key points. So write down a note and additional points. Just will summarize. L is equal to R cross P. So L will be equal to I omega, and L is equal to, this P can be written as R cross mv, right? So this can be written as m into R cross v. So R and V should be perpendicular to each other. So let's do some questions. I just summarize the points. You can write it as a note. Write down a beautiful question. We need a beautiful answer for this one. A particle of mass m is moving with a constant velocity v parallel to x-axis. Its angular momentum about origin. Its angular momentum about origin is what? Okay, so we'll answer it up. It's a beautiful question. Angular momentum about the origin. I'll give you 1 minute to answer this one, or 2 minutes. Angular momentum. It's angular momentum. 4 options. Increases. Option B, decreases. Option C, constant. Next option, first increases and then decreases. First increases and then decreases. What you will choose? Angular momentum first increases you will choose, or decrease you will choose, or constant you will choose, or increase and decreases. Normally we have a tendency, which one is the biggest option, that will choose. Option D is the correct answer. Correct? Wrong answer. Option D is not the correct answer. Let's see what is the answer. A particle of mass m is moving with a constant velocity parallel to its x-axis. Its angular momentum about the origin. Angular momentum point is important. With respect to which point? About the origin. Let's draw the diagram. So we have an x-axis and we have an y-axis. A particle which is moving parallel to x-axis, so it is moving, this is one point, after some time here, after some time here, after some time here, after some time here, and it's going on like this. So the positions with respect to the center, for example, suppose if it is will be here, then the position vector is r, and this is the direction of velocity. We know according to angular momentum, wherever you see cross product, this should be r perpendicular, this should be v perpendicular, this should be r perpendicular, this should be momentum perpendicular. Momentum perpendicular means momentum is mv. So mass is scalar quantity, so r and v should be perpendicular. Suppose if this angle is called theta, it's not given in the question, we are just taking as theta, then we have horizontal component and vertical component. Vertical component is this one, horizontal component is this one. What is horizontal component? R cos theta. What's the vertical component? R sin theta. So I can say this height at this point is equal to how much? R sin theta. Okay, but when the particle shifted its positions to here, now earlier it is at the point of 1, now it's moved to 2 and 3 and so on. Suppose now it is moving to the next position. Suppose it is touch 2. So it's not r, it's some other value called r dash. Okay, but the angle is not theta, it's some other value called theta dash. So here also we have two components, right? One is r cos theta dash, r dash cos theta dash. Another one is r dash sin theta dash. So r dash sin theta dash is this component. This is r dash sin theta dash. See, but here I can say one conclusion is that r sin theta is equal to r dash sin theta dash. If you take another component, then r double dash is equal to sin theta double dash, and it's going on. So what is fixed will be here. Vector r is fixed. So if you substituted in this formula, n equal to m into r cross v. M is already constant because it's a mass is changing. R means r sin theta, which is equal to r dash sin theta, which is equal to r double dash sin theta. So r is what is will be here. R is constant. Okay, r is constant means r will be equal to r sin theta. Perpendicular distance to velocity. See, this is velocity. This is your perpendicular distance. Perpendicular. So v and r makes, r is going like this one. So it makes 90 degree. Both are perpendicular to each other. If it is perpendicularly, you can do. From the origin, it's perpendicular. So origin r aanu. So r cos theta, r sin. So r sin theta is perpendicular to your velocity. So both are perpendicular. So e distance is r sin theta, or this is r dash sin theta dash, or it is r double dash sin theta dash. All these are equal. So the perpendicular distance are equal. Velocity is already constant. Okay, already constant. Where it is given, already constant. Where it is given? It is given in question. It is given in the question. If it is given in the question, m is constant, r is constant, v is constant, my answer is also constant. Okay, my answer is also constant. So r, v, all are constant. So the angular momentum will retain it as a constant value. Important. We'll move to the next problem. Okay, we'll go to the next question. Next problem. Hope this is clear. Angular momentum about a point, about the origin. From the origin you have to start to draw. That is the aim of the thing. Okay, let's write the next beautiful question. Next beautiful question is a ball of mass m. A ball of all this question and answers given, everything should be there on your notebook. Otherwise you will never qualify NEET or JEE. A ball of mass m is projected with a velocity v, with a velocity v at an angle 45 degree with respect to origin. Find the angular momentum. Of the ball with respect to the point of projection. When the ball is at maximum height, ball is at maximum height. Question, beautiful question, so let's see what is coming or will be here. Let's do. So this is a question which is clubbed with the two-dimensional motion. I know you already studied two-dimensional motion. If you have not studied, no problem, we can study now. This is initial velocity u, and this is which is given in the question with a velocity v is given. So our u is equal to v, that's all. And this velocity, this angle is 45 degree. When the ball is at the maximum height, we have the horizontal component of velocity that you already know. You say u cos theta, sir. Okay, sir. I will say it is v cos 45, sir. This is correct, sir. V by root 2. This already you know, sir. I know, sir. So v by root 2. Question is, find the angular momentum. Find the angular momentum of the ball with respect to the point of projection. With respect to from here you have to do. With respect to the point of projection when the ball is at maximum height. I will take another color. When the ball is at maximum height. So now this is my r vector. This is my velocity vector. This r vector I have to split. See, now this angle is 45 degree. This is not equal to 45 degree, correct? The blue one is 45 degree, the red one is not 45 degree. So how should I find? A distance vector which is perpendicular to velocity? That means this is my distance vector, right? So I'll say this red one is not 45 degree. So this is my, what is this? H max, maximum height of projection. H max, maximum height of projection. What is the maximum height of projections? Tell me. H max, maximum height of projection is means what? H max, u square sine square theta by 2g. This is the maximum height. Solved. So maximum height will be equal to r. So what is our formula? Angular momentum is equal to m into r cross v. So m into r perpendicular. Okay, and v should be perpendicular. Okay, so let's substitute m into what is r perpendicular. What is r? R means what? R means h max. H max. So h max means u square sine square theta by 2g into v perpendicular. Rendu perpendicular, then only you can multiply. What is v perpendicular? It is v cos 45, which means v by root 2. We'll simplify this one. M into u is given in the question as v. I told u is equal to v. So v squared sine square theta, that is theta is the angle of projection, that is 45 degree. So 1 by root 2 into square 1 by 2 and divide by 2g, u square sine square theta by 2g into v by root 2 into v by root 2. So the answer is what? Answer I am writing over here. Okay, so mv cube will come on the numerator, mv cube divided by 2 will come down, 2 into 2 4, so 4 root 2. So 4 root 2, that's all. My answer is over. Angular momentum is mv cube by 4 root 2. Pakka correct answer. Okay. Okay. We'll do some special cases. Special cases we are going to answer it. Some special cases. Important ആണ്. Special cases എല്ലാമേ. Special cases, special question മാതിരി വരും. Special question means all the special question everybody will not answer. Only some special students will answer. That's what we are saying special. 45 questions edutana physics il there are some 5 to 6 or some 6 to 7, 6 to 8 questions are difficult questions will be there. So only some special category of students, those who are going to secure ranks, will answer only for that. So we also want that. So for that we'll answer what will happen. Special cases. രണ്ട് കേസ് ഉണ്ട് സ്പെഷ്യൽ കേസസിൽ. നമ്പർ വൺ സ്പെഷ്യൽ കേസിൽ നമ്പർ വൺ, when the particle is moving in an horizontal circle, horizontal ആയിട്ട് ഇങ്ങനെ പാർട്ടിക്കിൾ റൊട്ടേറ്റ് ചെയ്യാം. ഓക്കെ, പാർട്ടിക്കിൾ മൂവിങ് ഇൻ horizontal circle ഇങ്ങനെ മൂവ് ചെയ്യും. ഓക്കെ, let me see what is a special, what I am trying to explain it over here. It's very hard to draw, but I will try. Okay, so here we have tangential velocity v, and this is our r. When the particle over here, this is our tangential velocity v, and this is our r. When particle over here, this is our tangential velocity and this is r. When particle over here, this is our tangential velocity and this is r. Okay, so everything we have drawn, but it's very important. Listen to me very carefully. Particles, listen very clearly to my hand only. So the particles which are undergoing a rotational motion, particles which are moving in a circular fashion, the point is like we have to remember what are the things which are constant, or what are the things which are always changing in terms of different factors. Different factors means you know the angular momentum is a parameter which is equal to, listen very carefully, complete attention is required, complete 100% attention is required, then it's very clear. Okay, complete attention, 100% concentration is required. So if particles which are rotating in an horizontal circle, or horizontal circle, the particles which are rotating, if it is rotating in an horizontal circle, there are the radius everywhere inside, and ഓരോ പോയിന്റ് എടുക്കുമ്പോഴും സപ്പോസ് ഇതാണ് ഫ്രണ്ട് സൈഡ്, then ഇതൊരു ബാക്ക് സൈഡ്, then ഇത് അതിൻ്റെ ബാക്ക്, then this is rotating. Now if you take the front side over here up to here, what is the velocity? Velocity is like this, and radius is what? Radius will be coming like this. Now look here, particles are rotating. Now I am going to find out the direction of the angular momentum. So it is r cross v, right? Our formula will be is equal to, so L equal to m into r cross v. Both should be perpendicular. That's what we told. This is perpendicular. So this is moving with a same velocity, a constant velocity. Radius is also constant. So r is constant, velocity is constant, magnitude wise L is constant. But now the particles over here, and it is moving like this, and r will be like this. So let's see, r cross, I placed my right hand like this, r cross v. So v in the direction I have to fold my forefinger. So r cross v. So now the particles are going like this. So when it is reaches at this point, velocity is like this. So r cross, so r cross v. So where my thumb is going upward. So at this point, okay, so remember one point, do not look into board, only look into my hand. So r cross, so idana r cross v, ഈ finger folded, so thumb is going upward, direction is upward. Clear? Now the ball will be here, the bob or the particle will be here. Now it is coming to this side. Now it's coming to this side, means velocity is in this direction. So I'm using r cross v. I'm folding my hand, r cross v. So where my thumb? Upward. So now it's coming, so it is going to complete one circle, and the next one reaches on my chest, the circle at the point. So here velocity is like this. Okay, so and the radius is like this. So I am turning to this point, and it is r cross v, thumb is upward. Then this point, this is the next one here, r cross, so r cross v folded, so thumb is upward. So in the entire circle, if a particle is moving in a circle with constant velocity, its angular momentum is constant in terms of magnitude and in terms of direction. So L is equal to mvr is constant, in magnitude and direction. In magnitude and direction. Direction is where? Always upward. Always upward. You can also practice all this mudra. You have to practice, then only you can answer it. So he is always upward. Okay, so the condition will be here. V is constant. V constant namle magnitude visum, direction visum, it is constant. It is fixed. It will not change. Adana adinte meaning. Okay. Okay. Next we'll see the next special case, the second case. Very important. This sentence it will be get confused. But what is the meaning? Everywhere you have to use what is the rule I have applied to use this one. Right hand palm rule. Right hand palm rule. Or I can say right hand thumb rule. Anything you can say. But tuck 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 tuck. This one. So velocity. Sorry, R, V. So here R is like this, V is like here. R is like this, V is like this. So wherever. So in this position we have the R vector, V vector. So thumb will give L. Resultant. Two vector cross in the resultant on thumbs up. Okay. So we'll go to the next one. Next one is what? Next one is in the concept it's very much connected over here, and the concept will be here. We have this circle like this, and we have calculated the angular momentum. Okay, here we have calculated where angular momentum with respect to origin. So L with respect to origin we have calculated. Origin means we are starting from the origin. Next, angular momentum with respect to the point P. So this position this will be the direction R. So here we have a velocity like this. Okay, here we have a velocity. So what is the angle between R and V? What is the angle between R and V? It's 0 degree or 90 degree or something else. The angle between R and V is always 90. See, just listen. So this is a point over will be here. So I am drawing a line like this. So if I'm drawing a line exactly, so this is the point. So this is a circle. This circle is the top center of the point fixed. That point I am drawing a line to one edge. That line I am drawing one edge. That is the radius to create an angle. Okay, so this is the velocity vector. So this is the radius vector. Radius is like this. Now this is called mr cross v. R this one. R is like this. Velocity is like this, right? Right? Velocity is like this. R is coming like this. See? So what is the angle between? So R is coming tuck, pakka. So what is the angle between them? It's still 90 degree. So this angle is definitely makes 90 degree. So our formula whatever which is given will be correct. We can use it. But now this is one point. Whenever it reaches on this point R, we have a velocity vectors like this. But we'll see what is the speciality over here. Listen very carefully. Now your velocity will be here. This one, this red color one. And let me take my blue color pen. And this is your R vector. So now you know your velocity and R are perpendicular to each other. So R is coming from here, slanting position. So R, V, 90 degree. Both are making 90 degree. Now we have to find out the direction. How to find out the direction? R cross V. So R cross V. Okay, let me remove it and we'll simply we will say we know it is R cross V. So we have to fold in this direction. So our hand should come like this. R cross V. So angular momentum is in this direction, not exactly like the slanting position. So R cross V. Okay. Now you see the other position. Now the velocity will. Now the body will be rotating. Now the body will be reaches over here. Now your R will be like this. So R cross V. So it is in this direction. Angular momentum is in this direction. Now when it is reaches, when it is rotated to my backside, I am come here. Now this is going. So tangential velocity like this. R is coming from here. So R cross. So R cross V. Angular momentum is like this. It's not always up straight upward. It is some slanting like this. So here it is like this. Here it is like this. Here it is like this. And here it is like this. So what is different will be here. direction is different. So magnitude wise it is constant. So as V is constant, and angular momentum with respect to which point? With respect to P. With respect to P is equal to M into R perpendicular into V perpendicular, only we multiplied. But what is will be here? Magnitude constant. Magnitude is constant here. Magnitude is not changing. But what is changing over will be here? Direction is changing. Magnitude is constant but direction is changing. Very important on two cases. First case magnitude constant, direction constant. Second case magnitude constant but direction is changing. Okay, that is the speciality of angular momentum. Angular momentum with respect to which point you are calculating depends upon that, you will get a different answers. So angular momentum with respect to P. So P is started with respect to origin. So you will start from origin upward. You will start from origin. You will start from origin. You will start from origin. So constant, always straight upward. But another case, you are starting from here, R cross V, going there, R cross V going here, like this, not upward, some slanting positions. Okay, hope this is clear to you as well. Okay. We'll do one questions out of this one to get some concept of angular momentum. We'll do one problem, then we'll wind up for the sessions. Okay. Okay. So the question is, find the angular momentum. Question is, find the angular momentum along the diagonal. So we have a square which is given, and we need to find out the what can I say, the angular momentum along the diagonal positions. So this is a square which is given side A length. We want to find out angular momentum along this line. So angular momentum along this line is called moment of inertia along that line into omega. So what is the angular momentum along this line? So this is like you can consider like this is a two triangle, right? For two triangle lamina, we have already learned what is the moment of inertia of a triangular lamina about the base positions. Which we already learned. So this moment of inertia we know, and similarly it is just like a connection of two triangle lamina. One is this one and one is this one, right? If you turn like this one, you will get this one. So if you know the moment of inertia of the triangular lamina about the base position, and you find out the triangular lamina for the other one also. Okay, the base position. So this base position and these two will get the moment of inertia for the total triangular lamina. What is that? Ma square by 12 if you add that and multiplied with omega. So this will be the answer. So this is the moment of inertia of a two triangle. This is a square. Is square e side moment of inertia to calculate. To calculate that, you have to add the moment of inertia of the triangular lamina about this side. So about this side, if you add, you will get the moment of inertia of the two bodies. So for the first body plus second body, ma square by 12 you will get it and multiplied with omega, because L is equal to I omega is the question over here. Now I will clarify how you got this ma square by 12. Maybe some of you might have a doubts. So this is actually, I have written here root 2a. So this is a and this side will be root 2a. Now previously we have learned about one square lamina concepts. A square lamina which is about this axis of rotation with a height h will be equal to I is equal to mh square by 6. This already we learned, right, for the triangular lamina. But here in this case the height means this area we have to calculate. So here we have a 2 1. So the total mass will be equal to m and one side will be equal to a. So but in our cases this is like a 2 structure. Okay, for one structure we can calculate. So one structure, what is this height? This height, this is also a diagonal, so root 2a. So half of this height means root 2a by 2, which is equal to a by root 2. appa idile ee cases le h is equal to a by root 2 aanu idinte height. Ini what about the mass? Idinte full mass aanu m. So within a portion half edutha m by 2. So for example, this is like I can say I1, and I1 will be equal to m by 2 into h square by 6. What is h square? M by 2 into h square means root 2, a by root 2. So a by root 2 the square by 6. So how much will come? This is m a square by root into square root 2. 2 will come to denominator. 2 into 2 4. 4 into 6 24. ഇതാണ് I1 ന്റെ കേസ്. I2 similar ആണ്, exactly the same. So I2 is equal to I1, which is equal to ma square by 12. Moment of inertia ആണ് we are going to calculate. This is for a square lamina. അതിനെ രണ്ട് ട്രയാങ്കിൾ ആയിട്ട് കൺസിഡർ ചെയ്തു. സോ എം എച്ച് സ്ക്വയർ ബൈ 6 ആണ് ജനറൽ ഫോർമുല. അപ്പോൾ ഒരു ഹാഫ് എടുക്കുമ്പോൾ മാസ് എം ബൈ 2, എച്ച് ഈ ഹൈറ്റ് അത് റൂട്ട് 2 എ ബൈ 2, വിച്ച് മീൻസ് എ ബൈ റൂട്ട് 2. സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു I1 I2. സോ ദ ടോട്ടൽ മൊമെന്റ് ഓഫ് ഇനർഷ്യ I is equal to I1 plus I2, which means ma square by 24 plus ma square by 24. This is comes as ma square by 12. This, if you remember, you can remember. This is actually we are substituted over here and we got the answer for this question. Okay, hope this is clear and this is very clear to you. Now we have completed till the concept of angular momentum. Next topics we have other areas such as conservation of angular momentum and rolling motion. Few more topics are left, and yeah, we'll see with the next sessions and hope you get something from me. Okay, so thanks for watching it.